Hello, everybody, and welcome to another episode of the Industrial Wi-Fi Shop. My name is Scott McNeil, and with me is the hostess with the mostest, Jeremy Baker. How you doing, buddy?
Good. Ready to spin some letters there, Pat.
That's fantastic, the Vanna to my Pat Sajak. Um, Today's going to be a lot of fun. We've got a round table going on, and we're going to be discussing specifically wireless challenges in industrial and manufacturing environments. And today we've got longtime friend of the show, Justin Shade from Phoenix Contact. How you doing today, Justin?
Doing fantastic. How you guys doing?
Not too bad this way. And we have a first timer on the show today, Troy Martin from way up in the Arctic regions of Canada. How are you today, sir?
Outstanding. Yeah. Calling in from the Canadian Rockies today. Glad to be here. Thank you.
Well, welcome to the show. We hope you have some fun. Um, the usual housekeeping events. We got Wyco going on all over the place. So be sure to check the website. I'm rocking my Wyco shirt today, actually. Um, Wyco, North Carolina is June 11th, just outside of Greensboro, North Carolina. I will be there amongst a bunch of other people. The speaker lineup is fantastic. JJ has done a really good job of getting things squared away for it this year. And it's getting so packed that with any luck, next year we'll be able to turn Wyco, North Carolina into a flagship event that will expand to a 2-day event. That's really kind of what we're pushing for, and that's what we'd like to do. And with the numbers that I have been privy to so far, it's looking like that's a strong possibility. So it's going to be a lot of fun. So if you're in the tri-state area, North Carolina, South Carolina, Virginia, Tennessee, come hang out with us. I think there's one or two tickets spot left open. And have some fun. Otherwise, check the website, see what's going to be close to wherever you may be, and check it out and let's have some fun, right? Also, don't forget on the mothership, industrialwifishop.com, we do have our document downloads page where we have all kinds of fun stuff and information to share out with everybody, from conversion tables to best practice documents that we're always trying to add more to and expand on to share the knowledge so that everybody gets just a little bit better, right? So today we're rocking a roundtable discussion. And so how I've got this laid out is I've got 11 different topics listed out in our show notes. And we're just going to kind of take our time going around the horn. We'll pick one and then we'll throw it out to the group and discuss it and see where it goes. But before we jump into that, Troy, why don't you tell everybody a little bit about yourself for those who do not know who you are, sir?
Yeah, absolutely. So yes, formerly I work for Ookla as part of the Ekahau division, looking after Wi-Fi design tools, scanning, testing tools. But in my past life, I've worked in many different industrial environments, a whole range, including things like pulp and paper, nuclear, oil and gas, pipelines, pharmaceutical, the whole gambit. So I've seen a lot of different deployments, the good and the bad. We've deployed mesh, point-to-point, video camera backhaul, mustering solutions, lots of really interesting things, often in an attempt to backhaul wireless sensor information. So I'm super excited about where this conversation is going to go today.
Awesome. Well, we are super glad to have you and glad you could show up and join us from the frosty nethers of the Canadian Rockies. Justin, holding things down in Pennsylvania. How have you been, sir?
Busy. A lot of stuff going on right now. So just trying to stay afloat and helping customers out and finding solutions for, not just wireless now anymore, my new job, but all things automation.
Well, how long have you been with Phoenix Contact now?
I think June 19th is coming up my 20th year. So
20 years. You are old.
I am old, lost my hair, but that's how we move up in Phoenix. Once you lose your hair, you move up the chain. So I'm,
Oh, is that how it goes? Okay.
Just a sign of wisdom.
yes, all the management has no hair. So I'm on my way.
That's awesome. Well, I tell you what, Troy is the first timer, so we are going to give him first pick. He can spin the wheel. And which one do you want to kick us off with today?
Oh, other topics. Let's jump into Maybe to get us kind of set and leveled, maybe we want to talk about some of the differences between industrial Wi-Fi and enterprise Wi-Fi, that classic IT versus OT discussion.
That's a fair assessment. Um, well, I mean, right off the bat, uh, this is something I talk about ad nauseum, well, with people just in general. So I'll try not to sit here and make everyone's ears bleed. But when it comes down to it, IT and OT, we use all the same gear, but it's a different school of thought behind the two, right? So in the IT universe, if you need to go reboot a switch or a server, you have certain times you can go do it, or with some places you can just go do it whenever, because who cares if Sally in accounting can't get to a cat video for 10 minutes, right? No big deal. Who cares if email gets a little delayed or whatever? Or if you get a little bit of jitter in a VoIP call because spanning trees reconverging in the background while you reboot a switch. Well, in the OT universe, we can't do that. So if we go out and random reboot gear for any reason, it could stop the process. And depending on that process, it could be something detrimental, especially if you're dealing with chemicals. But that's just one main difference in the schema of IT versus OT. The other really big thing, as we all know, sitting here, is environmental. And that's a huge deal right there. And I don't want to sit here and run my mouth the whole time. So
I guess, Troy, do you have a good elevator pitch you usually use for the difference between the two?
Yeah, so I often come back from a security perspective, and often on the security side of things, I talk about the CIA triad. So the confidentiality, integrity, and availability. And generally in enterprise, right, you want to make sure that things are confidential, right, that your secrets are safe. And when you send a message, that the integrity is there, right, that the message that you sent is actually the message that's delivered. And then availability is kind of that third one, right? If it takes a little bit longer, maybe not a big deal, but as long as we hold on to the C and the I, we're in good shape, right? The table's a little bit flipped in the industrial space. I think the availability kind of floats up to the start, right? When you send a message, you want to guarantee that message gets there, right? If you're closing a valve, although you do want it to be a safe and secure communication, but if everyone can see that you're closing a valve message, what matters more is that you get that closed valve message there than keeping it safe. Now, from integrity perspective, when you send the close valve message, you want to make sure that the close is the message that's sent and received, right? So there's a little bit of a caution there, but it's just an interesting way to look at the different perspectives and focus in the industrial space, right? And that's where there is a bit of a discussion of Wi-Fi versus 5G, and I know that's one of the other topics there, but it kind of ties into that whole availability, that guaranteed delivery, the high reliability of communication. That is the big emphasis in industrial space, where your enterprise designs today, we talk about, for modern Wi-Fi designs, you want to make sure you account for capacity and massive sets of bandwidth, large files. In industrial space, it's not necessarily massive files. It's just making sure that that message gets there when you need it to. I've seen other conveyor belts where some safety control systems that they need that message to turn off the motor to stop the safety or stop the belts from moving in case someone sticks their arm in the path. That message needs to get there in less than 50 milliseconds or people are losing limbs, right? If you can't guarantee that message delivery, your system's not going to perform in the industrial environment. So that's just kind of a high level difference between the two.
it is so refreshing to me to hear somebody else reference the CIA triad, because I literally my guys at work get sick of me even talking about it. But that's really one of the best things, comparatives you can use, because that translates directly into IT speak that so many IT folk understand. And doing up little simple graphics of the CIA triad versus the AI, what I call the AIC triad, and different things like that. I use that all the time because you're absolutely right. That's a really good introduction to someone who doesn't understand the differences, but they are a technical person.
I was going to add to Troy's about availability is that in a lot of industrial applications, whether it's wired or even wireless, best effort packets don't exist in a lot of situations.
That's fair.
it has to get there. It must get there all the time. The availability must there. I did an application where they actually turned off the encryption and the encryption of a Wi-Fi network because it was slowing it down enough that it was causing problems on the system. And it was an oil and gas application, so it was in the middle of absolutely nowhere. There was no one around. So they did their analysis of, if someone's going to come out here and try to mess with us, we'll take that risk. But this data, we're losing thousands of dollars a minute if this communication doesn't happen. So they actually turned off the security of the radio because it was slowing it down too much.
Well, I mean, that kind of leads directly into another real difference between OT and IT is, well, in OT, we really have to play it on a case-by-case basis. While we may have standards and guidelines and things that we want to follow and that we want to try to attain, it's going to be a case-by-case basis because if you put controls in there like security and it is inhibiting the process, well, then that's got to go. And you have to figure out some other way to implement some type of security. But, that just goes to show you that it's a unique case for every site that you go to. And it's,
well, you look at
with IT, you can pretty much standardize across the board because you're not worried about that.
Yeah, and a lot of OT applications, it's a lot different than enterprise, where enterprise, it can be, it's a public place, right, where anybody can go on. So you have to have those the specific things that are securing your network and making sure people aren't getting certain places. Again, I've talked to a lot of people where they're worried about, hey, what if they push this button? What if they do this? Well, there are layers of security. First one being physical on the plant. Like if you're worried about someone pushing that button on that radio or pulling that plug, aren't you first worried about how they actually got to the control cabinet or how they got on your property? Isn't there a layer there that you should be worrying about first before this one little minute aspect you're looking at, maybe the hardware or a light or something on the radio that could cause a problem? Again, that's been conversations over and over again that people aren't thinking about is that gate isn't locked to get onto your property, right? Versus you're walking through, a campus where there's Wi-Fi, the guest network is wide open, right? That there are different security measures for a campus guest network versus an industrial process.
So
Justin,
I'm sorry. Go ahead.
No, I was just going to say, we definitely see that going to sites too, because I'm not going to say what it is, but it's a metal fabrication plant that I went to several years ago, and the gate guards are just like, "Oh, you don't need to check in, just come on in," and it's like, this is not a good, It's just, there's like so many other things before just like physical access to a cabinet. And even, the joke is that, the flathead screwdriver is the cabinet key.
Well, I mean, this whole, we've kind of morphed and we're really hitting another one of our topics. So I'm going to go ahead and take my choice and I'm going to I think we should talk a little bit more about the security. Because that is an obvious difference, but one of the more outside things that I don't think a lot of places take into consideration when you're looking at a manufacturing facility is just how far outside of their facility their wireless presence goes. And so where that becomes directly important is I have been to sites where they're just running open connectivity. And it's a site that's right next to a neighborhood. And so they don't understand that they are pushing so far beyond their physical boundaries that I was able to go into the neighborhood next door to the site and pull up my handy dandy cyberscope and do PCAPs and get all the information from their open networks. So I'm not even on site. There's nobody even to look at me because I'm just sitting in a car on a street. So I'm not worried about physical security. I can access everything from there. And in a case at another mill, I was helping them with their crane anti-collision system. They didn't have it secured. Their idea of security was the infamous hide the SSID. Well, the problem was I could see that at that MAC address from almost a mile away because these radios are on top of cranes. So I did a quick capture on that channel. I got everything I needed. And from sitting in my car, after looking at that PCAP, within 5 minutes, I had a static IP assigned. I was on their network. I did a full scan, and I was looking at their Allen Bradley controls for their anti-crane collision system. How scary is that? But it's knowing that how far off of your site that you're pushing your wireless signal, because it's just going to keep going, you know. Um, and even then, you can be, as we all know, you can be on the fringe of actual connectivity, but it doesn't matter if you're just trying to capture data. You're not pushing anything back. You're just listening. And at that point, you can listen a whole lot and get a quite the bank of information before you even attempt to go anywhere closer and do anything nefarious, right? Um, and then even at another site, they were on the Intercoastal Waterway. And I've talked about this one in the past. While I was there doing an assessment, and the guy I was working with had a boat, so we went out on the waterway just to see how far out uh, all of their wireless propagation was going. And you could be center channel in the ICW and pick up everything. He was connecting up and logging in with his phone, his work phone on their wireless. And that's a pretty big problem when you consider they're right next door to an international port. And on the other side of that was a very large local marina. And then on the other side of them was a boat ramp that the general public used. So you have no idea what kind of boat traffic's going up and down there, right? Let alone international traffic because of the port that's right next door, which, by the way, you could see all of their wireless too. But theirs was, secured. Well, this site was for the most part secured, but the fact of the matter is you don't know who's listening, right? And that's the big gotcha when you're pushing so far beyond the physical boundaries of your site. And I just think that's a piece of the security puzzle so many people either forget to or just don't think about looking at.
And also, we talked a little bit about the layers of an onion. When you try to protect your network, you should have multiple layers of defense, safeguarding your systems. And when you hear, people are able to connect to a wireless network and, get into the core and get to the keys of the kingdom, to me, that screams that those multiple layers weren't in place, right? Those networks weren't segregated or partitioned off. There's no way that an open wireless network should have direct access, or even in an industrial control system environment, a physical path to get to other areas of the network where it could talk to your distributed control system or anything like that. So to me, that sounds like a breakdown in the fundamental architecture design of the system.
Agreed.
Now, on
Completely
the flip
agreed.
side, I see why people do that, right? You have operations teams on sites. They want access to certain metrics, operational information that can help them make better decisions on, when to schedule turnarounds, for example, on devices. If they can track changes in vibration of motors or turbines, things that spin, they can predict when they'll fail, right? So they know, if we got a turnaround coming up in 6 months, do we service this equipment during that turnaround, or do we service something else? Where do we, better allocate our resources when we turn around? Because we're not making money during that turnaround. Now, to get access to that data, sometimes they're making compromises in the wireless systems that they're turning up. But their efforts, I think, are with good intention, trying to get access to that data. But that kind of strikes to the differences between the IT and the OT side of things. In OT, where they want to make things easy, easily serviceable, kind of obvious. If things break, you can just swap parts out and they automatically reconnect, rejoin. Minimal configuration needs to be applied. If you customize and tune things too much, now you need an expert to be there to reconfigure things when anything gets swapped out, if it's an access point, a wireless sensor, or a switch. And that becomes problematic to restoring connectivity. So they want things to be simple, whereas the IT mindset of things is we need to put in like this very robust, this very rigorous configuration that locks down, hardens everything, that's very customized, but you need a very strong skill set to understand what's going on. And that's not necessarily what's present physically in a lot of these remote sites, where you're just happy to have hands and feet able to, screw a new device onto a tripod or a pole or into a rack.
No, you're right on the money, because the OT does not have the depth of bench for technical talent in that aspect, right? They have all kinds of controls guys, they have all kinds of E&I guys, but What you don't see a lot of are OT network people, OT network architect people, people who specialize in that stuff. And then when you go to half of these sites, it's not so much with the newer sites, but with brownfield, you go out there and it's one large flat network, and you have controls on there with other data, and the broadcast traffic. When you do a straight PCAP, the broadcast traffic is 60 to 70% of that traffic, and it's coming from 15 different subnets, and it's all on the same VLAN. So that kind of eliminates your defense in depth right there, especially when you're dumping it all in there, which why it's really important for that defense in depth to include segmentation for those wireless pieces. So if, God forbid, one of those wireless pieces does get compromised in some fashion or another, it's only that one segment, and it kind of locks it down to that, you know. And that's a painful lesson I think a lot of older manufacturing and dirty manufacturing is learning now, that they really need to get in there and they need to start proper segmentation and other baseline security measures. Because that's what I preach. Is I preach the basics, because all of your advanced stuff, like clarity, the clarities of the world, the Nozomis, the Dragoses, they're not going to do you a lick of good if you don't have baseline segmentation and the proper firewall policies built in to limit direct communication.
Well, that all goes
None of that's going to help.
well, that all goes back to what Troy was saying earlier, right? It's about all availability, right? So these manufacturing plants have been running for years and years and years with a flat network all in one VLAN. Because why? Because it works, right? And in a manufacturing plant, what do you not do? You never touch something that's running. So of course they all want to do this. They all want to do this update because everybody's seeing the stuff on the news about, malware attacks and ransomware attacks and everything like that. But what do they have to do to make this big change? They have to shut things down. That's the only way to do it, and they can't afford to do it. So until they have some pain and someone gets in there and hacks their system, or they see some big vulnerability, it's going to sit the way it is because it's worked like that for years.
Well, and then that translates to a lot of guys who are gun shy about wireless. It's a lot of the old school engineers that have been out there. They have a bad taste in their mouth for wireless because, and let's face it, in the industrial universe, if you can hardline it, you want to hardline it. But
Why not?
wireless truly has its place. And with all the advancements of wireless over the past 15, 20 years, it has been creeping in slowly but surely in just about every manufacturing environment out there, as maybe not a mission critical process, but absolutely a desired and needed process. And a lot of it has to do with something you touched on, Troy, with preventive maintenance and sensor packages and things of that nature. But even then, you want to make sure that those are locked down, segmented, and secured, right? Because if they're not part of the direct process, they don't need to be on that process network.
Mhm.
So all of your sensor data, you can kind of do out of band and send separately up, because a lot of that is also cloud based. And what's the last thing you want to really enter into your OT network down in the depths of production, in your what I refer to as your cyber reality, because this is where cyber decisions actually have real world effect. To Troy's point, opening a valve, closing a valve, starting a conveyor, stopping a conveyor, right? That is not something you want to expose directly to the internet. That's not something you want out there in the cloud. Many years ago, I met a guy at the Security Week ICS Security Conference in Atlanta, and he ran a project called Project Shine from 2014 to 2016. And all it was he took the Shodan search engine and modified it specifically to run amok on the internet, looking specifically for Siemens and Rockwell controls devices that were exposed directly to the internet. And what he found was ungodly. And the reason he even stopped doing the study was because it wasn't slowing down. Every month it was finding more and more and more and more of all of these that were exposed directly out to the internet. Now, granted, this is 10 years ago, so a lot of things have changed in that aspect. But when I was reading through the results, it was crazy to me how many of these controls devices were exposed directly with no security, no password. You could log right into them, or they were factory default passwords. So it's a simple Google search. What's the default password for XYZ? So if that's not reason enough to scare you that you don't want that in there, then you also have to look at all these wireless sensor suites and packages that are all cloud controlled. So if you want to do that preventive maintenance sensor package, whether it be LoRa, whether it be wireless HART, or any of the other things that aren't controlled locally, that you need the cloud process for applications, then you need to do that completely out of band. So it's not part of that OT network in general. But that's my diatribe.
And I think you hit the nail on the head there. Like a lot of the value that wireless brings to the industrial network, I certainly don't think we want to use it for safety and not closed loop control, right? That puts us a lot of risk. And I think we'll talk about RF challenges in a bit. But ultimately, wireless is vulnerable to jamming attacks, right? With a strong enough or complete enough jammer, you can ultimately knock out wireless systems. Some of them have built-in mechanisms to kind of hop around interference, but you just have to be more creative in your attack vector to entirely knock it out. So to your point about, if we could wire everything in, we would, right? It's really, really expensive to wire sensors all over the place. It's very cost effective to put in wireless sensors all across your plant and tap into all that rich diagnostic information that gives you more insight. It's not information you need to control the plant itself, but to understand the health of the plant, of that network, what's going on, which allows you to make a lot of more intelligent operational decisions, which saves you a lot of dollars, a lot of expense, a lot of maintenance costs down the road. Right? And if that system goes down for whatever reason, you just miss that window of operational information, right? It doesn't cause the plant to stop producing or a batch to stop mid process or anything like that. So it's super, super helpful, but you need to be mindful of how you connect that infrastructure into systems, making sure that it's segregated on the right network. But there's also a risk that with all that information that we're talking about, and we feed this into all of our AI systems. I had a really interesting conversation with a gentleman a while ago that sometimes data presents a problem, right? So the scenario here was they wanted to put in wireless sensors inside wells because periodically these wells were flooding. They were filling, they had fiber cables running through these wells, and they'd start losing connections. So they wanted to know when there was water in the wells so they could drain them, right? And right now their solution was once a month, they'd physically walk to the well, check to see if there was water and drain it. Right? And so they do this check once a month. Now with sensors, they could check that on a minute by minute basis if they wanted. And it turns out the wells were flooding once a day.
Oh,
It's
wow.
just sometimes they drain faster. And now they realize that they didn't have the resources to go in and drain those wells every day. They only had the resource to allocate once a month to it. So with this extra data, it actually generated more work for them. And they were okay draining the wells once a month. They just couldn't find resources to get to it once a day. So there's an interesting problem that now that you have the data, does that put more workload on you as part of your infrastructure and plant? Maybe it was good not having that data because it didn't create more work for you.
But then that leads to mystery problems you're trying to troubleshoot, right?
It's the
So,
trade-off, right?
right. Well, I prefer to be in the category of the known as opposed to the unknown, because at least then you're aware.
Make a decision off it, right? Whether
Right.
it's important enough. Yeah.
That's where deploying wireless sensors, like it allows you to make those decisions, right? The more sensors you can deploy, and it's just extremely cost effective, whether you're using, like you mentioned, wireless HART, HALow, Zigbee, ISA 111A. Like there's lots of different industrial specific applications that you can use that give you some resilience in the wireless environment to make things like that work.
You better watch out listing those standards. Scott's mouth's watering.
Woo!
This is IT versus OT, not wireless standards.
Right. I'm not gonna go on one of those diatribes. So, Justin, it is your turn to spin the wheel, sir.
I think I'm gonna go with mobility and roaming with AGVs and AMRs.
Hmm.
I actually have a real life one I think that's been popping up a lot more recently that I think is pretty interesting. So in Pennsylvania here, I deal with a lot of material handling, and I have a pretty big customer that does AMRs for their own facilities for a lot of returns of hardware. Um, So they designed their whole AMR by themselves. They actually built it from the software up. It was pretty cool. And they deployed their first ones and using enterprise access points, existing warehouse access points with our radio on it. And they were running into a roaming issue. The radio would just stop in a spot and they couldn't figure out why. And we were in touch with their IT guy. Everything was great. We were really good guy, was offering all his help, which we could go into a whole other conversation where that IT versus OT personnel conversations are negative, but this guy's really great. And he's like, yeah, man. He's like, I'm looking at it. Your signal strengths look great. You're in the negative 50s the whole way through everywhere you go in the warehouse. It's great. I don't see any roaming issues. The roaming times are good. And I'm like, okay. So I looked into our radio. We have a signal strength server you can track. And I'm looking, I'm like, yeah, we're in like a negative 70s the whole way through. Like, I don't understand why we're seeing. So I can see like we're bouncing access points because our threshold's like negative 60. We're like a negative 65, 70 the whole way through this place, the whole way through the facility. And it clicked in my head. I'm like, what's your power output in your antennas in these APs? And he's like, well, we're at like, 10 8, I think it was 8 or 10 dB power output, and they had an internal like 2 dBi antenna. I'm like, there's the mismatch. I'm like, we're 100 milliwatt, we're a 20 dB radio, and we have a 5 dB antenna built into our radio. So I'm like, you're hearing us, we're shouting at you, and we can barely hear you. You can hear us, but we can barely hear you. So we had to go through our radio and kind of adjust the roaming thresholds and the signal strength things to make it not bounce access points so often. Because basically what was happening is their traffic control system was losing it. We're roaming so many times so quickly that the traffic control couldn't keep track of where it was going through these access points. So it was just a light bulb moment that was like, we didn't match up our signal strengths and our output powers between the two devices because it was an enterprise device versus an industrial device. And again, the basic settings are different because we have different end goals with our products.
Mm-hmm.
So that was just a really interesting thing. Once we leveled up those things, it started running perfectly. But it took us a day to figure that out and just marry up those power outputs and signal strength settings.
That's wild. So I don't know if it's a difference in Canada. We often call them autonomous haulage vehicles, but it's one of these terms like AGVs, HAVs, AMRs. Like, it's like we can't as an industry come up with a standard for this term, but whatever it is, it's always those trucks that are causing the problems. We have a somewhat similar story. They were using really old clients on the trucks, so they had hazardous rated industrial APs as part of their infrastructure, but on the trucks they were really old Wi-Fi clients. So they had two radios. But actually, it was more of those one radio stories, so like pre-MIMO days, right? So we're talking like 11G type hardware, that it was a primary and a secondary radio. And because they had the two antenna leads, they ran one antenna to the left side of the truck, just underneath the lid, and the other antenna to the other side. And they'd drive these trucks around their patterns, moving their dirt and grabbing their material. And in one direction, the primary antenna would be facing the access points, and they'd have really good communication in that one direction. But then the truck would go back the other way, and with the secondary antenna, it used that to receive, but not to transmit. Right? So the connection would be really weak. Right? Yeah.
Okay.
Yeah, like it's super bizarre. So that always good connection one way, horrible connection the other way. And ultimately what the challenge was for these guys is they wanted to deploy completely autonomous vehicles. But they need to give their position and coordinate the position of all the trucks throughout the mine, that when a truck lost connection to the network, they basically lost visibility to where that truck was. So there was this safety bubble that would then radiate from this truck, like so this imaginary kind of bubble. And when that safety bubble came in contact with another vehicle, that vehicle would stop moving, right? Because there's a chance they could be colliding. And then that truck would have a safety bubble start radiating out from it.
Is it a physical bubble?
Well, it's a virtual bubble that the system kind of implemented. Once it loses visibility to a truck, it creates the safety bubble and then gradually shuts down all the trucks as everyone gets tripped by this virtual safety bubble because no one knows really where any of the trucks are, right? And then communication would restore, all the bubbles would disappear and everyone would start driving. But then it would happen again. One truck would lose communication. It would trigger like multiple safety bubbles. And so they'd be up and down and up and down. And every time the trucks stop moving, they're not moving material, right? They're not making money. And these are kind of the trucks, like when a chunk of oil sand, falls out of the back of the truck, it's the size of a Volkswagen Bug, right? Like it's a big chunk of material, right? So these are like 40-ton trucks moving a lot of material. Like there's a lot of dollars being lost when these trucks aren't in motion, right? So very problematic. But kind of going back to like with kind of basic understanding of Wi-Fi, understanding like power budgets between the access points and the clients, and matching those in both directions, or how communication is sent across multiple antennas, or the problems with legacy Wi-Fi technology. These are a lot of things that are I find often overlooked in industrial applications, and it's a lot of the solutions, like the entire package of a solution, they'll standardize on various pieces that then get signed off by that implementation. And so if you want, as the end user, if you want to start customizing components, upgrading different pieces, if they're not signed off by the implementer of that entire larger package, it becomes difficult to implement upgrades or patch management or change the hardware to improve these devices over time.
And I think that sometimes comes down to like like in my situation, the person who was designing this device, it was a vehicle, but it could be a cabinet, it could be a static thing. They're usually like either a software or an electrical engineer, and their job is to design the control cabinet, design the device. Oh, I need a radio. I can put a radio on top of this control cabinet. They don't have the training to know that, will this radio match up, or even know to ask the question, does this radio match up with what I'm going to be connecting to in a facility? There's like, oh, I just need a Wi-Fi radio or a cellular radio, or name your technology radio. I just need one. And then it gets on site and it's like, this doesn't work at all, or this isn't going to do what you want it to do.
Yeah, so true.
Justin, kind of adding to that, right? Like, you said that person, they see only their side of the conversation on that stuff too, right? So they're like, oh, it's got great signal all around. And I think for us, especially like in mobility, it's always something like that. Like you have to, if you don't have a good like RSSI logging on the client, you have to manually do it and just kind of drive it around a spot to make sure that you have that antenna match.
Mm-hmm.
Or you're talking about those old clients. We get probably 2 or 3 calls a year, older vehicles that have like the PCI cards in them, and it's a lot of times it's not so much like an RF thing, but it'll be like a passive client thing on there too, where and I'm not going to say the vendor, but it's prevalent on there. But you say, hey, do you have such and such controller? And they say, yeah. And you say, did you update the controller recently? Yeah. Did the problem start around then? And it's just like some of this stuff is just it's supposed to still be compatible, but it just isn't. And we're, like Scott and I will talk about this a lot, is like our product life cycles are, kind of work against us sometimes on the tail end, because that stuff's been around for so long. And then you start putting this newer stuff on and you want to say, hey, we're only supporting this minimum data rate moving forward, or we're going to use these wider channels, or like things like that. And that stuff will get you too.
Mm-hmm.
Yeah, you're absolutely right on that. The whole legacy equipment, just due to life cycle management, is so much different in OT, which goes back to our first thing. That's another huge difference between IT and OT, right? Is device life cycle management, because in most IT, it's what, a 3 to 5 year replacement cycle. Back in another life, when I worked in higher ed for a college, we had a 5-year rotation. PCs, network hardware, whatever. We had it all scheduled out. And OT, that's not a thing. You expect to get a good 10 years minimum out of the equipment that you put out there in the field, because once you're running, you don't want to stop.
Mm-hmm. Mm-hmm.
We've got some customers right now that are like still putting in, some stuff that's announced for end of life soon, and they're like, we're going to put this in, and we've been guaranteed replacements for an additional 10 years. And it's like,
good luck.
Yeah. Well, it's like the hardware's still going to be available, but it's like, man, who knows what's going to be, what technologies are going to pop up in the next few years. Because, 10 years ago, people had hotspots, but it wasn't just easy to leave like accidentally on. And like every site assessment that we do, there's Devon's or Birdman or whatever it is hotspot, is on there. And it's like, this is that stuff is definitely like an interferer in AGV stuff, because we kind of touched on it before, but we're that the A and the I part of it, the integrity and the availability. If you have stuff creating that OBSS or like co-channel contention, we're really susceptible to layer 2 retransmission. And so it's a nightmare dealing with that stuff sometimes, because you can't, you could put the sign up, hey, no hotspots in the area, but
no, that's what I refer to as transient wireless, right? And anywhere you have a loading unloading zone, you're going to see a metric crap ton of that, especially with fleet trucks, because they'll have all manner of wireless systems on fleet trucks, right? PNet's one I see a lot. I think that's one of the big, it's short for PeopleNet, and it's one of the bigger fleet management systems out there. But PNet not only has a satellite uplink on the top of the truck, it also provides Wi-Fi for a ton of preventive maintenance sensors on those trucks. And so when they roll in, they're already emitting. And I stumbled across this, I don't know, probably 7-8 years ago when I was doing an assessment on a site down in Florida. And I was like, what is all this stuff? It's here today. It's not here now. And then I started tracing it down and tracking it down, and it was coming from all these big trucks. So I started paying more attention to that every assessment that I did, and I was seeing it every site that I went to. And then over the years, to your point, Jeremy, you're seeing all these hotspots. It's only getting more and more prevalent, right? So 8 years ago, doing an assessment, I might see 40 or 50 SSIDs on a given site that have nothing to do with the actual company. Now, when I'm doing an assessment, that's one of the little stats that I give them. And I want to say the last place I did had the better part of 400 plus different SSIDs unique. And maybe 5 to 10 of those had to do with the actual site. But all the rest was things from printers left at default, to people's hotspots on their phones, to the transient wireless of the trucking companies, and to flat out people's cars driving by. Because now wireless is so prevalent just on your regular day-to-day car. And instead of, I know a lot of vehicles that when I rent cars for travel, I'll connect up to the system Bluetooth, but then it transfers over to wireless. And so you're actually using 2.4 because it has better throughput than the Bluetooth does for all of your media transfers, to the now pretty much iPad dashboard that you have in all the new vehicles, right? So you have all that going, but God forbid you're close to a big highway, and then that's constant seeing that. So that transient wireless, that's a real thing and a real issue. So I'm totally with you on that, Jeremy.
Yeah, we did some sort of point to points on these. It's like a tracked crane that's got a claw that moves trees into a debarker. And man, this thing worked great. We did the signal measurements and stuff. And about 2 weeks after we left, they started giving us calls that, hey, this thing's dropping at the end of it. And we started looking around, and then finally, like, I got them to send some logs to me, and we were looking at it. And we're like, oh, there's overlap APs, and that was where the trucks would come through with the stuff on it, their hotspot. It was at the end of the run, so the SNR got so low that it was, it basically was interrupting communication. So we ended up having to do like a channel switch on that. But then there's also, we've been seeing a lot too, like, Troy and Justin, I don't know how often you guys mess with this, but we've been starting to look for, especially for like AMRs and AGVs in congested environments, like lowering the maximum data rate, because I know like the Siemens stuff wants to default at like the max MC, it makes all its decisions based on the signals, the signal strength that it has in it. So it'll try and send at like 150, 200 megabits. And and it's like, man, we're trying to get like a meg across this. And like, as soon as that signal degrades or there's interference or reflections, the retries just go crazy on it.
Yeah, it's so interesting you bring up that point. Years ago, I was deploying mesh networks, and so we'd put in two redundant mesh networks on 5 GHz on different channels. So it'd be like a primary mesh and a secondary mesh tied into our sensor network, which would be plugged into each of those. So if one mesh would go down, the other one would fail over. But the same logic got applied is instead of allowing those high data rates, I was capping them at 24 megs, right? Because we were trickling traffic through. Like the sensor network was at max 250 kilobits per second, but I didn't want to send a high data rate frame, bounce off a whole bunch of metal surfaces, cause interference, and then have to retransmit it. I'd rather send a more robust frame a little bit slower and just have it sent once. So I was trimming my higher data rates just like that. That's interesting that you say that.
Well,
Yeah, I mean
goes back to the triad, right? Availability is king.
well, it's really fun explaining to the end customer too. Like so you want to make the communication slower? Yes. It's like I'm like, this is still like 100 times more than you need. Like we're good. But yeah, it's there's so much stuff that goes into it, and that's where too, like with this stuff, learning about the fundamentals and like the zeros and ones of like how it actually transmits. And Troy, this just, if anybody's listening, you've got some awesome talks on like the signal processing and stuff too. Those I love watching your videos on that stuff. But it definitely, like, we have all these reflectors in there. We have, sometimes the MIMO helps, sometimes the reflections help, but sometimes it doesn't. So I think even too, like with the survey hardware, I was at a site recently, and we did, with our signal capture device, went around and we're like, oh, it looks great, and then when we actually ran the vehicle through there, it just couldn't keep a connection because it's the beacon frame that you're capturing in that survey is sent at that 6 megabit, and then everything else is sent at that higher data rate. So it's like, oh yeah, of course, just being aware of that, it was like, oh, this makes sense why it's probably failing on the actual data transmission.
Well, yeah, doing the survey with the device you're actually going to be using, right? That's what I always push to our customers too. They always like, well, can I just go off my phone and check this? I'm like, can, but that's not what you're going to be using, right? That's not where you're going to be mounting it. That's not where the thing is going to be sitting. Like, if you can get the exact device you're going to be testing with, like you said, the survey equipment's great for the first step, but then you have to go to the next step and actually put the hardware out there and make sure it's going to work in the place you want it to, the way you want it to.
Yeah. Hey, I can I can hold a Hot Wheels up and take a picture of it in my driveway, but is that going to look the same as the actual vehicle there? It's like just fundamentally different.
Yeah.
Well, Jeremy, it's your turn to spin the wheel, sir.
Oh man, I don't know. Let's see. Well, I think maybe this might be a good time to maybe start talking a little bit about emerging technologies, because I know there's a lot of people still on like the Wi-Fi, or a lot of the manufacturers still kind of have the Wi-Fi 4 stuff, but there's a lot of like the 6E clients and stuff are coming in. I know LoRa's pretty prevalent, but we're getting a lot of room, or maybe not room's the right way to say it, but like the Wi-Fi HaLow stuff is like really starting to put out some products, and I think that's probably kind of a good place to start. So where do you guys see like 6E in deployment? Scott, I know you've done some deployments. Justin, I mean, is that something, or do y'all have a 6E product out yet or coming out?
We do. So we have a 6E client right now. I think we were talking before we started recording.
Yeah,
our 6E. Yeah, we're with all. So for those that don't know, Phoenix Contact's a German company. So we're out of Europe, and there's a lot of Cyber Resiliency Act requirements coming out of Europe right now. So that's slowing down a lot of our releases because we have to abide by these new regulations. So from what last I heard, is our Wi-Fi 6E access points done, ready, but they're finishing up some Cyber Resiliency Act requirements so they can actually sell the product. So yeah, we're in that gray area of FCC seems to be done, hardware seems to be done, but for them to be able to sell it out of Europe, they have to have certain things done, which we're waiting on.
But that's for the full 6E access point, right?
Yes.
Because what's sitting behind me right here, those are Phoenix Wi-Fi 6E clients. They can't be APs in 6E, but they
Correct.
can be clients. And I actually have some of these deployed at a metal processing site out in Louisiana. And they're running off up against off an OT deployment of Wi-Fi 7, my first um, industrial, deployment of a Wi-Fi, full Wi-Fi 7 coverage in 6 gigahertz. And it's a Fortinet deployment, and I'm pretty happy with it so far. Had some firmware issues with getting 6 gig to broadcast properly, versus indoor versus outdoor, and that's kind of some of the we were pregame and talking about that too. But overall, I'm pretty happy with it. It'll be interesting to see because we're in the cutover process right now. It'll be interesting to see long term how it prevails because this particular site, there's lots of interference from their cranes in 2.4. So 2.4 is kind of shot when you look at it. They have site-wide IT wireless and 5 gig. And so as opposed to trying to coordinate with IT on channel space and this and that, they have nothing. IT has nothing in 6 gigs. So this was like the prime opportunity. And from a spectrum analysis point, it's a greenfield environment. There's nothing in 6 gigs. So this is it's been a really good experience from doing the survey all the way through to design and now deployment. And it's just going to be interesting how it goes long term because there's going to be stationary engineering stations on there. There's an SSID for roaming clients for engineers with tablets and different things like that, and then outdoors for their heavy vehicles for moving around all the steel stock. Those will be on here too. So it's long term. I'm excited to see how this goes. Since we conquered some of the firmware issues, there have been very few deployment issues in the grand scheme of things. And the industrial 6E clients are holding pretty strong. I've got some antenna issues. The antennas that I spec'd are a little weaker than initially anticipated. So we're going to have to figure out a solution for that. But the radios themselves are performing excellently. So that's kind of nice being able to put new technology out in a site as opposed to constantly falling back to Wi-Fi 5 or Wi-Fi 4.
Mhm.
Now, granted, some of these radios make a strong case for Wi-Fi 4 because they have like direct chip level access, and so that they can do enhancements for roaming and different things on the back end because they can do custom chip level code, right? But and what's not again to Troy's point earlier that the amount and Justin too, the amount of data we're trying to transfer, we're not doing HD cat videos. We don't need all of that. We're not pushing gigs worth of data. We're pushing data a lot of times just in the K or just in a few meg. So I see the argument for Wi-Fi 4, Wi-Fi 5, and not really moving forward. But there's also a security aspect that those older technologies are no longer capable of, right? So with anything 6 gigahertz, WPA3 is required. It's optional in 5 gig depending on what generation of wireless you have. And in Wi-Fi 4, it's just not going to happen. The best you're going to do is WPA2 enterprise, but and WPA2 enterprise is still strong, but we all know everybody always defaults back to running some sort of TKIP password, and it doesn't take long before those start getting out, and then all of a sudden everybody has access to it. And so your secure password is no longer secure because everybody knows it.
And also, the Wi-Fi 4 stuff, all the hardware pieces, the chips themselves are. I know if like some of our vendors we use, they're all discontinued. So you find a vulnerability in that chipset. Too bad. It is what it is at this point.
Absolutely. So with some of the other stuff that's emerging though, more than just Wi-Fi 7, and now we have Wi-Fi 8 knocking on the door, right? and I haven't been doing my due diligence on reading on what's going to be coming out with that. But when you look at industrial and manufacturing centers, you know, they're just now starting to touch on 6E and 7, right? And how long has 7 been out now? As far as fully ratified and out there in the known universe. And when you look at consumer devices, we're what past the better part of the 50% of the consumer devices now are Wi-Fi 7 capable. Well, we're just now in the industrial universe even starting to use those devices. So you can see how far behind that is versus enterprise and just standard personal use.
And Scott, I think too, it might be worth pointing out, some conversations I've had on the back end on the development stuff. Sometimes too, the manufacturer of the hardware might say, hey, there's not really, Wi-Fi. I know some vendors kind of just completely skip Wi-Fi 5. And similarly, like with Wi-Fi 7, they just said, hey, we're not really seeing any value in, retooling like proprietary protocols to work on this hardware because we don't really get that, you don't really get that much out of it for like industrial applications. Because there's one I know of that's, they said we're going to start developing Wi-Fi 8. I'm in my daughter's room and she just busted in on me.
Needs her office back.
Yeah, that's right.
We were one of those vendors.
Yeah,
we skipped 5. We were like the MCS table showing the signal strength and signal to noise ratio needed to get those high data rates wasn't, 90% of the time you weren't getting in an industrial environment. So what's the point of even developing something like that?
Yeah. And do you guys see any, I know it's kind of like the Wild West right now. Nobody's using it, but, is there going to be anything like the, with the 6E, with the 6 gigahertz frequency, is there going to be anything like that where like we have like random hotspots and stuff like that showing up, creating problems?
That's a good question. I don't know.
I think
Because I know there's stuff like, like the overhead light controls and stuff that sometimes will be interferes and stuff. But what are the do we see any? Are we starting to see any kinds of things like that are interfering? I mean, we recently had a line shut down at a plant because a TIG welder was being used near the line, and it was just in the perfect, EM. But it basically was like interfering on the channel that it was operating next to.
Yeah, one of the things that we've just noticed in 6 gigahertz from an interference perspective is coffee machines. So these are the high-end enterprise grade coffee machines. And what they added was a clever feature that when a human gets close to the coffee machine, there's a sensor that pulses and starts preheating the water so that it's ready to go when you walk up to it and you push the button and can start making your coffee. It's just this sensor pulses at 6 gigahertz. And so it's creating interference. And where we've seen it, it's they'll put one of these coffee machines, and this is more like industrial or enterprise rather applications, but every little kitchen coffee area on every office floor for like multi-floor buildings, they're putting one of the machines. So it's sending spikes all over the place. Or we've seen it in stadiums, right? So a lot of the box seating, those little rooms, they're putting one of these coffee machines in every one of the boxes, right? So there's a whole bunch of them all over the place. So now you think you have this amazing 6 gigahertz network, and there's a sensor knocking everything out, and it's on by default, right? So we had to convince them to send a maintenance team to go in after the fact, disable the sensor functionality on these coffee machines. So now you have to wait a little bit longer for your coffee to be made because it's not preheating. But yeah,
Interesting.
So we did a webinar just recently. You had to decide coffee or Wi-Fi. What's more important?
Yeah.
But was it like randomized on the frequency of the channel that was using, or were they all kind of set to where you could have avoided through a channel plan?
It seemed to be fixed. It was very predictable where the interference would be, so you could avoid it. But essentially, it's knocking out two channels on 6 gigahertz.
In a stadium application, I could see where that would be important because the more channels, the better. Wow.
Yeah, and then everyone hears it.
Coffee
Like once it gets
machine.
into the bowl, right? Like everyone hears that interference. It's a disaster, and it's
Yeah.
intermittent too, right? It's everyone walking into that room because it's motion sensors. Someone walks into that room, boom, that trips the sensor, right? So it was always kind of bursting.
Interesting.
And I could
That's
see
that's fun too because the we have stuff where it's like we've got some outdoor hardware that's needs to be on the fixed channel, and then they've got outdoor enterprise APs, and you get stuff too where it's like, okay, well, does that coffee machine as an interferer survive the like continued tribal knowledge of, hey, these two channels are bad too, and then somebody comes in and says, why are these disabled? There's no reason, and then re-enables it. So it's yeah, it's almost like, yeah, you probably should just, if you can disable it on the device and just leave that global policy in place.
yeah.
Well,
We
it's
we have
nice.
seen some sites that they'll create a position for a spectrum manager, right? So they'll be in charge of managing spectrum allocated for various technologies that show up. So for radios, for Wi-Fi, other wireless systems, safety communications, if there is an event that happens, that kind of thing. But a lot of these systems will be fighting over chunks of the same band, right? So they'll carve up the 5 GHz band or carve up the 6 GHz band and say, hey, this system can use, the Uni 3 channels, and because it's doing wireless backhaul. So it's the main backhaul uplink, but the Wi-Fi APs, they can only use the Uni 2 and Uni 2A channels, right? So now Wi-Fi, the mesh system that's being deployed is now subject to DFS hits and radar pulses, channel hopping, all those kind of events, possibly reduced transmit power, just due to the limited differences between, the Uni 2, Uni 2A versus Uni 3. Whereas it'd be much better from a Wi-Fi perspective to get access to the Uni 3 channels, but whatever reason, there's been a layer 8 decision that all this, independent separate wireless backhaul is going to get exclusive rights to that chunk of the spectrum, right? So it can help in certain situations, but now sometimes, a lack of understanding of the protocols can cause issues. And then I just wanted to show in a comment. I love the discussion about comparing the technologies, but I just wanted to point out from the business side of things, a lot of end users don't really care what technology you pick, right? Whether it's Wi-Fi, 5G, LoRa, BLE, whatever. It's just we want a sensor that can measure this, and it connects to this thing. Now make this work. And you ask, well, what wireless technology is it using? I don't know, but it measures vibration to the degree and caliber that I want it. That's why I want this sensor because it gives me the information and the resolution I need it. I don't care what wireless technology it's using, but I'm giving it to you, the wireless expert. You need to make this now work.
Yeah, I see that on occasion as well, and it's just that this is what we want. Can you make this work? And that's when you got to say, all right, well, you know what? It's going to cost you some research time on my part, but more than likely, yes. But the whole talk about the frequency and spectrum, and that's where some of the newer technology that is changing that into using 900 megahertz, like with HaLow and whatnot, um, becomes a big bonus because that's a whole nother area that you can then go to if you have that much congestion in five, or if you're using that much in six, for a much larger application. But with HaLow really finally, I mean, HaLow's been around for how long? I mean, as far as an actual, uh, what did we do? Was it like 5, 6 years? No, no, no. I mean, it's like closer to 10 years that HaLow has been
The
ratified around
ratification, yeah,
now. Yeah.
almost 10, yeah.
And it's just now getting to actual usable, deployable radios and whatnot. And I don't know what took it so long, but um, it's really, even though it's an old technology, it's really kind of a new technology because it's now getting, becoming usable because you're having the gear to do it. And it's not some, pie thing that you built with parts off eBay.
Mhm.
It's a fully manufactured, warranted, and supported device, which is really nice. But that also leads into other devices which are similar, but they're proprietary. We had the Esteem guys on not long ago, and I use a lot of their radios, their 900 megahertz radios, to do data links because they are doing what HaLow can do, and they've been doing that with their own proprietary and based protocols for better part of 15, 20 years.
Years, yeah.
You
Yep.
know, and that is a very attractive alternative when you're looking at some of these unique use cases that you have to have, where you're not pushing I don't know, 100 meg worth of data, but you are pushing more than just a few meg, right? But you also got to get that going a mile through trees. And it's going to cost you a ridiculous amount of money to do any sort of cabling out there. Um, and so, you know, it's not necessarily an emerging technology, but it's another alternative technology, I guess. Um, and then with Halo, or not Halo, with LoRaWAN, it's interesting with LoRaWAN because a lot of people they hear the buzzwords about LoRaWAN, but they have no idea of the data throughput restrictions of LoRaWAN. You know, because you're maxing out at 250K, which is fine for, you know, some individual sensors and whatnot. But then there's the whole back end piece that people, your average person, just has no clue about, because you have your LoRaWAN gateway. The vast majority of these are all cloud controlled on top of all that. And then you got to navigate your way through what gear is actually going to be appropriate to use, because so much of it is helium based and you know, this mining based, where you have to get tokens in order to make it work. And I went down this rabbit hole trying to build a lab kit specifically for LoRaWAN, and holy cow, there's not really a lot of stuff out there for a true lab kit that you can go and do POCs with, that you're not having to go, you know, that someone built on in their garage. I don't want something built in the garage. I want hardware that, you know, I can take to a site and I can test. And this is hardware that is, you know, current and supported by a manufacturer, and it's built for that environment. I don't want to open a box and see the shell of a Raspberry Pi sitting there, and a few home soldered wires, you know, in a clip shut box, and have it, you know, say industrial on it, right? But again, like I said, there's that whole back end piece of all the data processing on it that most people don't really think about, because on the front end, the actual wireless piece of LoRa is very simple, right? From a physics standpoint, it's very simple. It's 900 megahertz. You have certain channels you're running on. It's low data rate. It's low power, so on and so forth. No, boom, you're done, right? But then all of that extra data processing on the back end really complicates the things, and so you have to end up going with a vendor that does the full. That's all they do, is they do you know, sensor to data processing all in one suite, because they refined it. And which makes it kind of difficult for integrators like Jeremy and I to be able to get in there and work those pieces. And just interesting, because that's an emerging technology. While it has a proven use case, I see has some difficulties with deployment, if that makes any sense.
Yeah, so I think all the sub 1 gigahertz technologies are super attractive. The lower frequency obviously gives them a much longer range. And in refinery type environments, right, where there's metal tubing, piping all over the place, giant tanks, the penetration you get from that sub 1 gigahertz is extremely valuable. The trade-off, particularly with LoRaWAN, is significant bandwidth reduction, right? So that 250K, like that's a special mode of LoRaWAN. Typically, it's 50K or less, and just goes down from that. So I find LoRaWAN very effective for out-of-band management, right? So if I have a bunch of remote trailers that I use to deploy a Wi-Fi mesh network inside of mine, and I'll periodically move those trailers and rebuild the mesh, I like to put LoRaWAN sensors on it just to monitor, are my batteries charging, right? Do the batteries have power? You know, in a remote trailer or shack, is a door open or is the door closed, right? So I can get like binary bits of information. Did something on? Is it off? But now I know when I'm troubleshooting my Wi-Fi network, which is the real network I care about, is it even getting power? Is that why the AP is not, the mesh isn't converging? The node isn't coming up because there's no power, because you know the solar panel got cracked when a giant boulder fell on it, or you know hail came down and shattered the glass on the solar panel, something, or the trailer itself got buried by dirt and no one realized it. Now it's, you know, 20 feet under the ground, never to be recovered again. Like things like that'll happen. But I think there are some manufacturers that are geared for the industrial manufacturing space for LoRa. There is a lot of homebrew stuff, but there's companies like Tectalic or MileSites that do offer actually like the full package, right? So they have a series of the sensors, actuators, the LoRaWAN, the gateway itself. And they do provide the network and application servers. So that full suite of tools that you need to stand up a LoRaWAN system, you can purchase that from them and then deploy that locally on site. Whereas if you go down like the Helium kind of path or the Things network, something like that, that's more just to dip your toes, I think, in the LoRa waters. You can do some cool things, but I'm not sure I'd put it in
if you can figure it all out, for God's sakes. I mean,
yeah.
that was a
Lots
rabbit
of
hole I do
pieces.
not want to go back down again.
Mm-hmm.
So what's been your experience with deploying some of these LoRaWAN solutions?
Yeah, so I think there's a lot of concerns about scalability of these, right? So how many LoRa sensors could we stand up, right? Is it 100? Is it 1,000? Once you start pushing like 1,000, 10,000 sensors, is there enough bandwidth in the system for them all to communicate? How many gateways do you need? Right now, depending if you're North America versus Europe, there's different limits on how often you can communicate. So I find in Europe, I think it's you can only do a 40% duty cycle, right? So in a given hour, you can only talk, 40% of the time kind of thing. Whereas in North America, it's 400 millisecond talk intervals, right? So you can talk as much as you want, but I joke, I call it the Texan effect. You have to pause every 40 milliseconds, see if anyone else wants to say anything, right? If no one else has anything to say, then you can keep going. But every 400 milliseconds, there's a pause in communication, and that just helps the different devices talk. But with LoRa, you can send data at the same time as long as you use different spreading factors. So multiple sensors could be using the same channel transmitting at different times, and the receiver can still hear them given a different spreading factor, right? So there's a lot of different things going on, but that seems to be a bigger challenge is the scalability of it and just managing talk time. So people are trying to they really need to analyze how often are we getting data back. How often do we need to send bandwidth, and do we have enough throughput or capacity in our LoRaWAN network to make that work, right? And so some more of the industrial grade LoRaWAN gateways, they'll support like the full channel spectrum where they can listen on all channels at the same time. Whereas some of those Raspberry Pi modules, they'll only listen to like 8 channels of the spectrum at a time, which then limits how much capacity you have in your network. So there's a big difference, like I said, between like kind of the tinkering type of equipment that you get and what you'd want to deploy as part of like an industrial grade solution.
Interesting.
And then but I think there's a really rich a portfolio of LoRaWAN sensors and actuators. There's a lot of vendors that have contributed, developed their own parts. The downside is some of them kind of come and go, right? So they may not be here in 7 years, in 10 years, which could be a risk with LoRa. There's a handful that have been around since the beginning, and very likely they'll continue to be around. But you got to pick and choose, and then so that's where kind of going back to that point about people pick their sensor because it measures what they want to measure. They don't necessarily care about what underlying technology it uses. So you need to be very careful when you evaluate things that, hey, said, well, it says it supports LoRaWAN. Right. Well, how well does it support the full implementation of the standard? HALow is very attractive. It's sub 1 gigahertz. Gives you the range, right? So the typical quoted range is 1 kilometer, but they've set a record at over 100 kilometers getting HALow to work, and they've done some tests where they've streamed video over 10 kilometers, right? So it does work longer than that, but I think a reasonable distance is a 1 kilometer type range, but you're getting multi-megabit throughput
Right.
over that, which allows you to backhaul video, some selective imaging, right? So you could have local sensors processing images locally, and then only backhauling images that are relevant based on when the event or a trigger happened, that kind of thing. You can set up a lot more devices. A lot of cool things in HALow are things like target wait time, where now it's brought in scheduling to the devices, right? So instead of more of the classic, contention, listen before talk kind of thing, there's still a part of that, but they're given scheduled intervals on when a subset of those devices can talk, right? So if you had 100 devices connected to a Halo AP, you could assign like 30 to one interval, 30 to another interval, 30 to another interval, and now you're not competing with all 100 devices, only with 30 other devices for a talk time. So it guarantees or reduces your latency for the time that you need to send a transmission. So those are some cool enhancements that have arrived with Halo. And it's an emerging technology. I absolutely agree with what you're saying there. And I think what's held it back is that we don't see the depth of client devices
Agreed.
with Halo available that we see with other devices. And that's, I think, kind of slowed its adoption. But it's a sound technology. We just don't have the option for devices yet.
I think that's been the holdback because nobody's really been dedicated because it's kind of one of those chicken before the egg, or which came first, chicken or the egg scenarios, right? Because you need use cases before you want to commit to producing the devices. But it's kind of hard to get use cases when you don't have the devices to go out there and do a proof of concept with, right?
Exactly.
So, but to your point about the however many second kind of standoff time waiting for me to get, all that's going to do is enhance the scalability of overall of Halo, making it even more attractive long term.
Yes.
Yeah, that's good
Sorry,
stuff.
what's the most like amount of clients that you've tested like on a Halo link?
Yeah. So
Because aren't they supposed to be able to support like 1,000 clients, something
yeah,
like
it's
that?
crazy. They're up to 8,000. Right, so they've modified the formatting structure of the IEEE, the headers. 'Cause basically, Halo's built on Wi-Fi, right? So
Right.
it's the Wi-Fi frames just at sub gigahertz, but they've modified values. So for the AIDs, they've robbed 2 bits, which allows the client counter to go up higher. Now it sounds crazy, and from an enterprise perspective, you'd be shocked and think that's ridiculous. But the scenario for these things is a lot of your sensors will sleep, right?
Yep.
And they'd only report
Absolutely.
during an event, like a door opens, door closed, or hey, a cat ran by or something. We need to send you a video of this. So they could be dormant for 24 hours, 36 hours, and then send one image. So you could have 8,000 associated, but they're certainly not all transmitting all at the same time.
Right.
Most of them are in a sleep state, so to speak. Now it costs money for all these sensors, so I have certainly not stressed 8,000 devices. The highest I've got up is just 10 devices. So I don't
Okay.
think like a huge scale. Some of the deployments I'm working with more the agricultural space. So we're standing up scarecrows in the field for farmers. Typically, they've used an LTE 5G type solution where they pay a few $1,000s for the scarecrow, and then every year they have to redeploy and reactivate their scarecrows. So they pay a $500 hookup fee every year. What we wanted to put in is something like Halo, where we backhaul all the data from these scarecrows that are measuring things like sunlight, temperature, soil moisture,
Environmental
and also be able to
sensor
take
packages. I got you.
Yeah.
a video of the field, right? So as your little lentils are growing, you can get pictures of them and pat yourself on the shoulder every day as they're coming
Post
up.
them on Facebook.
Yeah, right.
My
Or
lentils
monitor
look
for things
amazing.
like lodging in your crops after a storm or something like that. So the picture is just a bandwidth available to backhaul over Halo a picture when it's useful, or like a short video feed. That becomes something very, very exciting. And to have a kilometer or 3 kilometer reach with these scarecrows, and something that I don't have to pay like a reactivation fee every year and like a monthly subscription fee for 5G, private
Mhm.
5G backhaul. I think that's a great use case for a Halo type technology.
Well, where that video feed out in agriculture really becomes handy then is late at night when the aliens are coming down and doing their crop circles. You actually can
Yeah,
get the video evidence, and then you can go and be on an episode of Ancient Aliens, and then everybody knows it's real.
yeah. And that's the ultimate payback for implementing this system, right?
Absolutely.
Aliens.
That's good. Yeah, I could see that on the pivots too. Because as those go around and like take pictures of stuff, and then they have a lot of those sensors where they'll like bury the sensors in the soil and stuff too. I know there's like a potato one that's
Yep.
that basically like stays with it through to production.
Yeah, and actually, when they harvest
I just
potatoes, it gets harvested up with it.
when you said scarecrow and sending pictures back, I was just picturing like really funnily scared looking crows, like pictures of them like freaking out, getting sent back.
And while not necessarily a new or emerging technology, wireless I/O has come a long way. And so even then, some of the proprietary stuff with wireless I/O is pretty strong too, um, because it can use that sub gigahertz bandwidth to get that distance and whatnot, and a lot of it scales pretty well. The Rad 900s, what do those scale up to, Justin?
I've seen one 13 miles.
13 miles
So
for
yeah,
wireless I/O. That's not too shabby. And how many devices can you set up in one of those uh m- mesh units or
it would
deployments, right?
depend how you're using it. It could be anywhere from like 98 to 250, depending on how you're using it. I think the biggest one I've seen was a redundant network for oil tank monitoring, where it was 85 on each side. They were just bringing in an analog signal from each tank just to float on
Right.
the tank. Yep.
So it's just amazing to see how even how older technologies are progressing, um, and becoming more advanced, more scalable, um, and utilizing the other the non what I kind of refer to as non-standard frequencies, right? Because you say wireless, everybody immediately thinks Wi-Fi, everybody immediately
Right.
thinks 2, 4, or 5, right? And now 6, and so there's all kinds of sub gigahertz conversations to be had out there. So do we have time for one more, guys? Because we've swung back around, and Troy, you will get the final spin today.
Oh,
Or I also have my son's Dungeons and Dragons dice I can roll. So
well, let's roll the dice.
let's roll the
Indeed,
dice.
less pressure that way. Roll the
All
dice.
right, this is a 10. Let's see now if I get something that we've already done.
D10.
Roll.
What'll happen?
All right, I got a 9. So let's talk about some designing for uptime and resiliency. So redundancy, failover, backhaul options. What's good enough look like in production environments? So I always think back of something Keith always says is that mesh is terrible. Keith does not like mesh. However, I think mesh in general does have its place in the universe, especially when you need some kind of redundancy. And so when we look at industrial deployments of any kind, redundancy is a key thing that is paid a lot more attention to in industry and manufacturing than it is in enterprise, because we want those systems to be redundant because we can't afford to have that downtime. Um, what I see, and it's interesting because I just did a nice little deployment of those Steam radios, and it is enabling me to have 3 redundant base units essentially, with a variety of other fixed point backhaul radios out around wastewater treatment. And so if any one of those goes down, it still has alternate pathing. Now it actually uses spanning tree on its wireless side, its own spanning tree instance. So you can actually kind of guide and figure out how you want that redundancy to go, which is really kind of nice. Um, and so you can actually dictate what pathings you want them to take. So I want all of them to come into base A, right? But if base A fails, I'm going to set my link metric so all of them will then fail over to base C, or base B rather. And if base A and B fail, well, then my metrics automatically fail over to base C, right? There are 3 different areas in the plant, so they all have different power supplies. So if a power event takes out one area, it's not going to take out the others. And so that kind of redundancy is really nice because these are all environmental sensors. The government wants its environmental data. And if you don't, if you're missing X amount of environmental data, you can be subject to some pretty big fines, because you're not reporting all that stuff in. And that's especially important for any sort of wastewater, right?
Mhm.
So that's really kind of one of the main things that I have personally done as far as designing for redundancy is wastewater systems.
So Scott, do those radios or ones you've worked with in the past, do they have ways of reporting their status back to whatever SCADA system you're working with or control system? So, like, is there a register or I'll say an API or an SNMP place where they can say, "Hey, I'm up, I'm down," so that your
I believe
main
there
PLC?
is, but that I have not gotten that in depth with those particular radios because I'm not a controls guy, Justin. That's where you have the leg up here is you have the the benefit of both controls knowledge as well as the wireless knowledge because I know you've integrated the two, right, to where you could actually control some of the wireless functions through a controller, right?
Yes, like our
Like a little PLC.
yeah. So I'm curious. I was curious, like, question because we have different products we sell. Our Wi-Fi radios have REST APIs, so you can pull that data off from a control system pretty easily if you can do API. But like our RAD 900s, our 900 megahertz radios, and some other stuff we've had in the past, there's no industrial communication for status, let's say. So if we're doing redundancy, how does the control system know which one of those of the three main radios are up and running, and how do they know if one went down, right? So that's what I've been asked for that in the past. You mentioned I was just curious if you run across it because a lot of people want hey, I want to query that radio, right? And just go, hey, it's up, the power's good, it's been up for this amount of time, or it's gone. I got an alarm saying I lost radio one, right? So I know
Right.
radio two and three are still working, but how do I know radio one?
So
Or signal strength of radio one's dropping. Tell everybody else to switch to radio two, right?
well, and that's when you look at various other just general monitoring, network monitoring systems. So
Mhm.
at this particular site, they use a system called The Dude by MikroTik because it's a really customizable graphic display that you can do and set up for network monitoring. And you can do just straight pings, you can do full SNMP, you can do a whole wide variety. Anything by MikroTik is like super crazy customizable, right? Well, The Dude, I don't know how it came to be called that, but it's free. But there's a lot of other network monitoring software out there that you can do that just do pings to let you know whether it's up or down. Or you can pull specific SNMP information from them because you can get the MIB libraries and download them. Now, as far as the Esteem radios, I'm not sure their full extent of their capabilities on that aspect. I know at this site they're just doing ping monitoring, whether the radio is up or down. So then we get notifications on when something goes down and when it comes back up. But I haven't done anything like fully integrated into the controls beyond that. No.
Yeah, because I'm thinking, if you think of the big manufacturer here in the U.S., Allen Bradley is the biggest control system seller. I've had people wanting to bring in status of the radios into a Rockwell controller, and if you don't have an EDS file or some kind of add-on instruction for your radio, you're looking at SNMP, which isn't necessarily native to the programmer's knowledge on how to bring SNMP into a Rockwell
Right.
controller.
Well,
So,
I mean, SNMP
Yeah,
could
we
be
see
an
that a
entire
lot.
career all by itself.
Yeah.
All right, guys, I got to take my wife to the airport. I've got a heart out. Thank y'all so much.
Pleasure. Thanks for having
Thanks,
us.
Jeremy.
You know what? That kind of works
Carry
out
on.
right. So, hey, you
I
know
don't
what?
know.
Thank you guys so much for coming and hanging out. I've really enjoyed this. It's been a lot of fun. So hey, stick around, guys. We'll be doing another episode here real soon. We hope you learned something. We hope you had a little bit of fun, and we'll be around to talk some smack again here soon.
Cheers, man.